Hello, welcome to Module 4, the cell cycle. The cell cycle is for cell division, cell duplication, for growth and repair of your body cells. So let me tell you a couple of stories. If we take a petri dish and we put in some agar, which is basically nutrient jello with sugars in it. We put a thin layer of agar in the bottom of the petri dish. We introduce some cells, some live animal cells, and what happens? The cells start to divide. And they divide until they're one layer thick, anchored into the agar in the petri dish, crammed up against the walls in all directions. If the experimenter removes a couple of those cells, guess what happens? The cells fill in. The cells start the cell cycle up again, duplicate until there's a one layer thickness crammed up against the walls. And we call this phenomenon density-dependent inhibition. So what's being inhibited? The cell cycle is being inhibited. The duplication of cells is being inhibited. And what is the inhibition dependent upon? The density of the cells in the petri dish. Cells follow density-dependent inhibition rule. If they don't follow the density-dependent inhibition rule, they grow and grow and grow on top of one another like this. We call this growth a tumor. Normally, cells are anchorage dependent. That means they need to be anchored to something. In the petri dish, the cells are anchored to the agar layer in the bottom of the petri dish. So there's the second rule that cells have to be anchored. They're dependent upon being anchored. Cells, they will not go into cell cycle if they're not anchored. Well, if cells somehow mutate and no longer follow the anchorage dependent rule, they start floating around in the lymph system and in the circulatory system, and they can set up a tumor wherever they want, wherever they land in the body. And we call this malignant cancer. So those are two stories and two reasons to study cell division.